Hi Nat5, so we've already looked at what types of abiotics might affect where things could live, but now you have to say, okay, well, how could you actually measure them? So this is about sampling abiotics, and mainly it's about how it could go wrong. So light intensity we'll start with. So light intensity, basically we have light meters, and all you have is a sensor at the top, or a row of sensors. Normally along the top of here you have a row of sensors here, and this is the sensor to sample the light. Okay, and if it's more than one factor, down here you can see there's a little kind of switch, so you can click it to where it needs to be. This one actually up here is one that's commonly used in photography. So if you were, and that's another reason why you would need to know light levels. So your problem with light intensity measurements are kind of obvious, but you need to be able to give at least one example and then how you would fix it. So here we go, you don't switch it to the right sensor. If you don't actually have it on the right setting, you can't be measuring light. Okay, shadows, that's quite common as well. So if the way you're standing can make a difference. So you've got to make sure that the sensor, you know where the sensor is, so you're not shading it by your own shadow. Okay, and then time of day, if you're trying to actually go and look at a particular environment and look at it in different places, then you have to go at the same time of day every time. Otherwise it's not going to be something that's a valid comparison, unless obviously you're trying to track changes over time, in which case it's important that you go at the same time of day but over several days, or maybe it's you go out for one day but every hour to check. So temperature, we're going to use just a thermometer or a probe. Not a particularly complicated thing. Basically we've got something at the end which we're going to place wherever we need it to be. This is a bit that's actually doing the measurement. Okay, this one is in here. So it could be part of another sensor. That's quite common. So this one looks like quite a complicated one. It's always got extra information in there. So all you've got to do is make sure that the bit that is doing the sensing is where you want to take the sample. And then you need to give it enough time, because quite often if it's a physical measurement like this one here, this is basically expansion of the liquid inside the bulb is deciding how far it goes up this. If you just stick it in and then take it straight back out again, it's not going to have had enough time to change. So you've got to give it enough time to register it and then record it. So errors are again kind of obvious. Okay, if you don't have it on the right setting, so check that, and if you've not given it enough time, so give it enough time. pH, we're going to use a range of different things here. So pH, you either use a probe, which looks very similar to some of the other ones we've got. So you've basically just got a bit that you push into the soil and then you read it off. Okay. Some of them have to be in a solution, so you might need to actually put the soil sample in, prepare it for testing. And then you can kind of use a slightly lower tech stuff. You could use pH paper indicator solution and then you put it next to a scale. This kind of thing, I mean, you buy kits like this for testing your soil at home if you're gardening. Okay, so this can be tricky sometimes to get it just right. So the errors for this are generally if you misread because you've not got it on the right scale, and then contamination if you've got something else that's causing a problem. So you've got to wipe off the probe each time, because otherwise you could take the result from the last one into the next one. If it's some of your more expensive digital probes, you've got to be very careful that they're kind of held often in buffers, which are kind of fancy solutions. And if the soil is too dry, then it just won't register at all. Now, not to go into a lot of detail on this one, but what pH actually is the concentration of hydrogen ions. So concentration, you should know from everything to do with diffusion, means you need to dissolve something. So if you can't dissolve it, you're not going to get a pH, so you're not going to get the reading. And as I said, the digital probes, quite often you have to store them very carefully in buffers, which are things that kind of are held at a particular pH. So there is potential for lots of kind of little things on the pH one. But I would say this is the best one to remember because it's the same one as the next one. Okay, because soil moisture, again, looks very similar. You can see it looks very similar to the pH ones. So you wipe the probe, you push it in, you read off the scale. Nothing complicated. So your error is not wiping the probe. So every single time that you use a moisture meter, you should be wiping the probe before you put it in and after, just because then that's ready for the next. And then we have our error that is always, always, always there. If you do just take one sample, it is not a very reliable sample. There could be an error just with what you've read, it's just not representative of the area you're looking at. So always, if they ask you how do you make this more reliable, you're like repeat it, please. And finally, your potential is not just to have any of these, you taking a thermometer and holding it in the river. Okay, what you could do is put in a probe and a sensor, hook it up to a data logging system, and then say I want you to take a measurement every 2 minutes for the next 2 days. And they will give you a much nicer set of data, really complicated information often, but you can break it down by using kind of data analysis stuff. So data logging can be really useful. And that's your abiotic measurements. Make sure you know which ones you need to know errors for and know at least one error so that you can give a reason for how you could fix it.